Hi guys. So today I'll be teaching on bearing capacity of CEG 414 Foundation Engineering, and I'll start by saying bearing capacity is used to determine the stress bearing capacity of the foundation. Today we'll be dealing with shallow foundations. There are two types of foundations, shallow and deep. But today we'll be dealing with shallow foundations. So a guy named Tezaki long ago worked on shallow foundations and gave 4 formulas for different types of shallow foundations. This formula, Q stands for ultimate bearing capacity. This is ultimate bearing capacity of the foundation is given by CNC plus gamma DF NQ plus 0.5 gamma PN gamma, where C stands for cohesion of the soil. NC is gotten from the table. NC, NQ, N gamma goes from the table. Gamma is the unit weight of the soil. DF is the depth of the foundation, and P is the breadth of the foundation. So this first formula was given for a street foundation. These formulas are just know them, just cram them. They can be modified. But this second formula, this is for a circular foundation, where 1.3 is added to the CNC and 0.5 changes to 0.3. For the third formula, this is for a square third formula, Q, the opening bearing capacity. This is for a square footing, and the last is for a rectangular footing. If you are good with the numbers, you know that for a square and rectangle, the difference is just that the breadth and the length are the same. So if B and L are equal to each other, then this is 1 minus 0.2 times 1, this is 0.8 times 0.5, which will give you 0.4. You know that 1 plus 0.3 times B over L, when B and L are the same, you know the 1 plus 0.3 equals 1.8. Situation where your soil feels locally, local soil field, let's say ASL, is an angle 5 of internal resistance for each soil, especially sandy soils. Clay soils usually have a low phi or no phi at all when it's saturated. The angle 5 changes to half tan 2/3 of 0.5. That is when your soil feels locally. There's a new phi that is equal to this, and because of this change, all these values have changed and multiplied by 2/3. So if I do 1.3 times 2/3, I get about 0.867. In the case of local soil failure, if specified in the question that soil fails locally, all formulas will become 0.867 here. 0.867 and 0.867. Alright, so let's solve some past questions to make everything clear. I'll be starting with the 2014-2015 past question. I hope you can get access to that. 2014-2015. Forgive me, all the earlier formulas just around with such that so that when I start explaining it, will be clear to you. So the question says, for the theoretical part, I'll advise you all read on depth in Marcel's demand tutors. So let's go to 1B. The maximum column load of a footing for a proposed building at ground level is 3,500 kN. That is the maximum column load. That is Q allowable. Maximum allowable load from the soil is 3,500 kN. The subsoil is a cohesionless soil with phi equals to 34 degrees. The soil has no cohesion, that is C equals to 0. Phi is given as 34 degrees. And that's a unit weight of 18.5 kilonewton per meter cube. So the unit weight gamma given by 18.5 footing is to be located at a depth of 1.5 meter below ground level. That is df is equals to 1.5 meters. And the footing size is given by d times n is given by 2 meter by 2 meter. Let me just quickly state this. When giving an area of foundation, your b is the shorter dimension. So if you are given, let's say 14 by 21, this is your b. If you are given 21 by 14, this is your b. Then another thing given, determine the factor of safety by preserving general shear failure theory. That is, they don't fail locally, just the original formulas I gave earlier. Factor of safety is what I'm looking for. If the water table is at a depth of 1.5 meter below the base of foundation, so the level of water table is 1.5 meter below base of foundation. Okay, a little sketch here. Maximum ground build of footing for proposed building at ground level 3,500. This is an allowable load. That is, the load that this building should be subjected to at maximum should be this. This is different from the ultimate load the building can be subjected to. This is the load that the building should be subjected to before it reaches failure. That is maximum allowable load. 3,500 per meter. So to get the Q allowable, this is the stress, just by the Q allowable divided by the area of the footing. So this is 3,500. We have, of course, the length and breadth, which is over 2 times 2, and this should give us 875
kilonewton per meter square.
All this is clear. Then I'd just like to add some other things. When doing foundation engineering, there's some terms that are used with bearing capacity. There's the ultimate bearing capacity, QU. There's the allowable bearing capacity, QAL. There is the safe bearing capacity, QS. It doesn't usually go for this essential, but it usually goes for this allowable. And there is the QNU, which is the net ultimate bearing capacity. So I'll just make the relationship very quick. QU is the general formula I wrote before, CNC, blah 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 blah. Since you are doing the square foundation, you have 1.3 CNC and you have 0.4 gamma P N gamma. Now Q allowable is given by QN minus gamma DF over the factor of safety. I'll just click the QS to explain that this is plus gamma DF. That is QNU minus gamma DF over factor of safety plus gamma DF. And QNU is given by so for the square footing that we're given in the question, 2 by 2 is obviously square footing, breadth and length are equal. We are using 1.3 CNC, we are using 0.4 gamma B and gamma. I wrote this earlier. Then Q allowable is given by QU, the ultimate bearing capacity, minus gamma DF. Gamma DF is the pressure due to the soil itself, divided by factor of safety plus gamma DF again. So can also be called overburden pressure when the water is saturated. From here, it's called overburden pressure. Then QNU is given by QU minus gamma DF. So that means this Q allowable, I can write it again as just QNU all over factor of safety plus gamma DF. Yeah, I think that is all we will need for this question. Level, the 1.5, the water table level is at the depth 1.5 meter below the base, not below ground level, below the base. That is, if the base is here, at the depth 1.5 meter from the base is where I have my water table. Let me just call this the water table. And there are some relationships as regards the unit weight for the water table. That is, if while writing the general formula for QU, which is 1.3 CNC per square footing, of course, for that we are doing it, plus gamma DF plus 0.4 gamma B then gamma. I want you to watch something else. This gamma DF only deals with this part of the foundation. That is the unit weight at this part times the depth of the foundation at this part. The gamma B here deals with the breadth of the foundation, but in reality, it deals with all the areas below the base of the foundation. That is, everywhere here is handled by the gamma B. If my level of water table is below the base of the foundation, it means it has nothing to do with gamma D. I would like to explain the effect of water table on the bearing capacity formula. I just wrote out the formula for a square foundation here. And yeah, so there are two conditions. When this stands for the depth of the water table, when your depth of water table is less than gamma D, and when your depth of water table is greater than gamma D. For the first condition, if it is less than gamma D, that means the water table is between here and here. Let's just pick a range at this point, where this will now be divided into H1 and H2. The overburden pressure, which stands for gamma DF here, will change. So let's say we had a gamma of 10 and a depth of 2, and before there would have been 10 times 2. Because of the effect of the water table, from this point down, for the entire of H2, your gamma will change from 10, which is your moist unit weight, to become the saturated unit weight to be given in the question. So let's say we have 10 here, and let's assume we have 12.5. This is just speculative. I'll give you random values. So for this top portion of your drawing, it will be 10 times 2. Okay? And for the second portion of your drawing, it will be 12.5 times, let's say your DF was 3 times 1. Where your gamma prime is given by gamma saturated minus gamma of water. Gamma of water is constant and always from 9.81 to the mean per cube. So this is for when the water table is less than DF, that is between your ground level and your depth of foundation. For other cases where the water table does not affect your gamma DF, please note only gamma DF is affected here, and this gamma B is affected when it is between the foundation. That is, this gamma here, for everything down here, is affected, it becomes saturated since there's water inside it. Once water enters the pores of the soil, it becomes saturated. That is, this gamma here also becomes gamma prime, and the gamma here becomes gamma H1 plus gamma prime H2. If the water table is at the ground level itself, everything here will just become gamma prime. there will not be H1, H2 because H1 will be 0, there will not be point. H1 is the point where your gamma is not saturated, that is not affected by the water table.
What is sigma V prime exactly?
Sigma V prime is known as overboiling pressure. It's the exact same thing as gamma DF. But it's gamma DF when your water is saturated. That is when you have the saturated water pressure.
So that means when the what do you call it? The water table is lower, is less than the depth of foundation, we will not use that gamma prime DF. We'll just use sigma V prime.
Yes, you can call it sigma V prime.
Okay.
Once the water table is between the ground level and
So when our water table is at the what do you call it? The ground level
the
itself.
ground level itself, it means that this formula will not include any gamma H1. It's just the gamma prime DF. That is the entire depth of the foundation is saturated.
Okay.
I hope you understand. And for the second condition,
As when given in the question,
is where
the water table
is below
the depth of the
the depth of
foundation.
the foundation. That is, your gamma DF here is not affected, it remains the same. But your gamma B here to have some effect on it. The formula changes. This is a new sign, gamma with a bar. Gamma bar is given by gamma prime plus D over B into gamma minus gamma prime. Where D is your depth of water table, let's just call this D. Please note that for this to affect gamma B here, the depth of water table
Has to be
has to be less than the breadth of the foundation itself. If the breadth is 2 and the breadth comes down here to the 2 meter, and your gamma DF, your depth of water table, rather not gamma DF now, your depth of water table is 2.5 meters below. It has no effect on your foundation. The water table is at a great depth away from the foundation and does not have any effect on your ultimate bearing capacity formula. But in the case where this becomes 1.5, like in the question, it's going to have an effect that is less than this 2 meter. It's going to have an effect on this gamma B. That is, your formula will change into gamma prime plus D over B into gamma minus gamma prime.
so that place will be having gamma bar B.
Yes.
So
This
that
becomes
means
gamma bar B.
the only time that will be true is if our breadth is greater than the what do you call it, of the depth of the water table.
Yes.
Well, in the question they gave us our breadth to be 2.
And
So-
depth of water table was 1.5 below the base of the foundation.
That means
Yes.
that if this thing, if the breadth is less than the depth of the water table, our formula remains the same.
If the breadth is less than the depth of the
Our
water
QU does not change at
table,
all.
QU does not change. It has no effect on gamma DF. It has no effect on gamma B.
On gamma B.
Let's go again one more time. If the water table is between the ground level and the depth of the foundation, it's going to affect your gamma DF and it's also going to affect your gamma B.
Gamma B. How does it affect the gamma DF again?
If it starts at the top of the ground level, itself, it means everything below the foundation is saturated. The entire soil from the ground level, that is, let's say this is the floor, from below the foundation, everything is saturated. That is, you have your overboiling pressure, same thing as gamma DF, to now become gamma prime
H.
DF. There's no H again.
Okay, at the
Because
top. Okay, yes, at the top,
where water
yes.
level is located.
So we'll just use gamma prime.
Where gamma prime is equals to gamma saturated
So minus gamma of water.
Gamma water is constant.
Gamma of saturated will be given in the question.
Yes, sir.
So if it is now between the bottom of the foundation and that ground level,
If it is between the bottom of the foundation, that is where DF reaches, depth of the foundation, and the ground level, that is at the point here, you divide this into
H1 and H2. So as overboiling pressure, sigma
our
V
overboiling
prime
pressure will change to become, that is, this first part has no water effect on it.
on it.
The water table starts from here, that is, everything below this point is saturated.
Okay.
But everything above this point
It's
is not
dry,
saturated,
it's just
still
soil.
dry. So this will just be a normal
Gamma H1 plus gamma prime H2. Makes sense.
Please, this is just for gamma DF. Again, this overburdening pressure is just for gamma
DF.
That is, gamma DF is the same thing as overburdening pressure. Let me put it there. Gamma DF is the same as overburdening pressure. They are not different. And if this entire point is saturated downwards, it means that everything below the base of your foundation is also going to be saturated. And your gamma for gamma B
now become gamma prime.
It becomes gamma prime B. That is, everything here is also saturated. Where gamma prime is the same thing as gamma saturated.
So this one does not have any relationship between the width and anything.
You don't do anything like this when your water is between the ground level and the base of the foundation. This does not hold. But if it ever surpasses, then use this formula. Again, if it surpasses, your gamma DF will be unaffected because it starts from here. It means that maybe at a point here, the water table acts, or at a point here, the water table acts. It means that everything between the ground level and the base
is not saturated, it's just dry.
You don't have this formula straight. But once it gets to below the base of the foundation, it will have an effect on your gamma B, which will become gamma bar. And your gamma bar, which I wrote here, is equals to gamma prime plus D over B to gamma minus gamma prime. Where gamma should be given your question and gamma saturated should be given your question. But however, after solving some past questions, I saw where the lecturer failed to put gamma saturated when your water table was below the depth of the foundation and still less than the base of the foundation. In those cases, just use your gamma as your gamma saturated. If it does not give you any moisture content, there's a relationship between your gamma dry and your gamma saturated. Gamma saturated is equals to gamma dry to 1 plus the moisture content W. But it doesn't give the moisture content. Like in the question we're solving, if you read through the question, there is no gamma saturated, there's nothing on moisture content. You just give gamma. In those cases, you have to use gamma and gamma saturated as the same thing. Except specified in the exam, at least you can complain to the lecturer in the exam, and if you change it, then you work with that. Ultimate, which is 1.3 CNC. Remember in the question, it said it's a correctional soil that is C was equals to 0. So 1.3 CNC, this entire expression becomes void, 0. Plus gamma DF, our gamma is 18.5. Our DF, our depth of foundation, as if from here to here, 1.5 was given the question. And our 0.4 into gamma bar, which is 16.05.
Was it not gamma DF into something minus 1?
Oh yes, you're right. This should have been Q ultimate, but since it's Q net ultimate, to be, thank you for spotting that out for me, to be gamma DF into NQ minus 1 plus our gamma bar, which is 16.05 times B,
which is 2.
Which is 2. Remember, the still meant to be 0.4.
Yeah.
Write it properly. 0.4 times 16.05 times 2 times our N gamma. So these values, N gamma, NQ, and NC, they are gotten from the table of angle of internal resistance. And unfortunately, I don't have the table with me, I can't write the entire table on the board. But it should be in gradual, that is, the information is behind by gradual, some make it by another very next meeting. And if there's good, can we just move it to come out? So since our phi was giving us 34 degrees, just a normal chart, where phi is given, we give NC, NQ, and N gamma. NC was 52.64. Let me make this clear. NC was 52.64, right? Our NQ was 36.5. 36.5, and N gamma value into this equation and press your calculator, you should have, let me reduce it. So CNC gives 0, that is this NC does not have any use, this will be 0. This will be 18.5 times 1.5 into NQ will be 36.5 minus 1 plus 0.4 times 16.05 times 2, that's equal to base of the foundation
times 36.04.
Again, this is giving me my Q net ultimate. That's why I was subtracted 1 from this.
But if you do not want to go through this, you can just find our QU, Abi,
Yes,
then subtract gamma DF from it.
so again, it gives the same answer. And
So
just draw out the question again, where our depth of foundation was given as 1.5, and level of water table was at a depth 1.5 below the base of the foundation. Our width was given as 2 meters. Our Q, that is the allowable load, was 3,500 kilonewton. And earlier we discovered that our Q allowable, that is the pressure, small Q, that was given as, which is given as Q over A, gave us a value of 875 kilonewton per meter squared. Again, earlier we said that Q allowable is equals to the Q net ultimate divided by a factor of safety plus gamma DF, where your Q net ultimate is given by your Q ultimate minus gamma DF. From normal mathematics, if gamma DF exists here and gamma DF exists here, you can collect like terms and just have 1.3 CNC plus gamma plus NQ gamma DF into NQ minus 1 plus 0.4 gamma B then gamma. Again, this will give me my Q net ultimate. That's when you subtract gamma DF from gamma DF NQ, you have this expression. So, moving on, our depth of water table is below the base of the foundation. That is, we have no problem with gamma DF, no issue. Our depth of water table is less than the base. That is, if I convert this base to become a vertical distance, it will be 2 meters here, and 1.5 is below 2 meters. That is going to have an effect on gamma B, and our gamma will change to gamma bar, right? So where our gamma bar, we agreed that gamma bar should be gamma prime plus D over B
into gamma minus
gamma prime. Again, I said in this question, we're not giving a gamma saturated. So we have to improvise and use our gamma prime to be equal to our normal gamma minus gamma water. That is, we are saying that our gamma saturated and normal gamma are equal to the same rather. So our gamma from the question, let me just clean this up a bit. This one right here, which I already converted it down. Our gamma saturated now will become 18.5, and our gamma water, which is a constant, is 9.81. This should give the value of
6.5 points. 6.69. 18.
That is our gamma prime. So to get our final gamma bar, I'm doing this out. I'll have my gamma prime, my gamma bar, sorry, not gamma prime, my gamma bar to be equal to gamma prime, which is 8.69 plus D over B. D over B, our depth is 1.5, that's our depth of water table. Our base is 2, that is below 2, and gamma minus gamma prime, which will just be 18.5 minus 8.69. This should be something like 9.81. If we did this equals to this, then this minus this should give 9.82. Okay, after expressing this, we'll get our gamma bar to become This is just calculator person. The gamma bar should be 16.05 right? So I think we're getting all we need to get our Q net ultimate. So as our Q net of diameter 1.05 meter was placed on the sand layer at the ground surface and loaded to failure. The sand has a unit weight of 16.5 kg per meter square. The failure load was to give a pressure of 1,500 kg per meter square. Sorry, this is meter square. And we have to determine the value of bearing capacity factor N gamma. The angle of shear resistance of the sand was found to be 39 degrees. And to compute this value with the theoretical value of N gamma, use CEG's theory of general shear failure. That is the only one we have been using since the next local shear failure. So to start with, we have a circular plate of diameter, let's say 1.05 meter. It was loaded to failure, that is the failure load, rather the failure stress gave a value of 1,500 kN per meter square. This is not Q allowable, unlike the first question. This is Q ultimate. It was loaded to its field. That is, its field, like this plate broke. Which means this is Q ultimate that we are dealing with. Again, our Q ultimate for a circular section is 1.3 CNC plus gamma DF N2 plus 0.3 this time gamma D
N gamma.
Yeah, we have nothing to do with
Question.
Yeah, our question was, is the questionless source, right? Yes, sand is questionless. Sand does not have question with its particles. Only clay and maybe peat have something to do with question. For sand, Cu equals to 0. This has nothing to do with water table. We're not giving any information on water table. If you can observe in the question, say a circular plate, that is, there is no depth of foundation. It doesn't go below. The foundation usually goes below the ground level, and from there below the ground level gives like DF, that is depth of foundation. But for a circular plate, it doesn't go below the ground level, which means for this question, our DF will be equal to 0, since it doesn't go at any depth below the foundation.
That's true for all circular plates.
Yes, for all circular plates. So which means from here our CNC C0, our DF
0.
I'm only dealing with this part of the equation, where our QU equals to 0.3 gamma B N gamma. Again, the question said we should find our
N gamma.
So let's move. We have our Q to give 1,500. We have our gamma to be 16.5. We have our B. Here our B will stand as our diameter, which will be 1.05. And we have our unknown that we're looking for, that is N gamma. This is just making gamma very to the formula. Sorry, I missed out 0.3. Let us add it to 0.3 times. So N gamma will be 1,500 divided by 0.3 times 16.5 times 1.05, and this should give a value of 288.6 degrees. So we compare this value. If we check the table, yes, no, sorry, it's not in degrees, it's just 288.6. It is the shear resistance of the degrees. When you check the shear resistance table, you find out that your N gamma from the table gives a value of 95.03, and here we have 288.6. The maximum value of N gamma should be 95.03, and we have the value of 288.6. Because compare the values together, due to the fact that what we calculated, our calculated n gamma is far greater than the n gamma.
Theoretical n gamma.
It means that your foundation has failed, which is just the point of the question, to understand to check our understanding of the ultimate bearing capacity. That if the foundation has failed, such that your n gamma is far greater than your theoretical n gamma, far greater than your theoretical n gamma. Therefore, foundation. So yeah, I've here you value given the value of 147.56. Just personal preference. I like to see this process. So if I see this equation, I have my Q and I in 175, I have my Q and U 1473.56. I can find my gamma DF. Gamma DF is equals to 18.5
times 1.5.
This should be about 22 points. Oh, not 27, about 0.75 to the limiting parameter square. It was also great to always put your units at back. So that means when you look for our factor of safety, just substitute and get the expression for factor of safety. So our factor of safety, FOS, will be given by Q
or minus gamma df
QO minus gamma df
over QNU.
No?
Factor of safety will be the inverse.
It will be the
Yes.
inverse of this.
It should be 1 over that. That's
This should be QNU
over
Q allowable
minus gamma df.
Okay, I'm saying so that our QNU to be 1473.56.
Is that what it should be?
Yes, that's what it should be.
Yeah, true.
Divided by our Q allowable 875 minus 77.75 is equal to the calculator to get something like 1.74. Again, factor of safety has limits. So this is the end of the question. I just ran through some explanations. Generally, this question should not take as long as it took. I just ran through some explanation of the effect of water table, or body pressure, gamma and all those. So, quickly, let's move on. This is for text.
So that means in reality we should know our formula for our square section, exactly
Yes.
formula for square foundation.
Yes.
Then now check if there is a water table effect on it.
Yes.
So the water table is just going to affect our gamma.
Yes.
So get QNU. Once we get QNU, use this formula for Q allowable to get our factor of safety. No stress.
So, let's solve a question on 2017-2018. Question 1b says the building is supported on a reinforced structural foundation of dimensions 14 meter by 21 meter. Again, the smaller dimension is the breadth, while the longer dimension is the length. The subsoil is clay, which has an average unconfined compressive strength of 45 kilonewton per meter square. I'll come back to this average unconfined compressive strength. The pressure on the soil due to the weight of the building and the loads it will carry will be 140 kN per meter square. At the base of the raft, the unit weight of the excavated soil is 19 kN per meter cube as gamma. At what depth should the bottom of the raft be placed to provide a factor of safety of 3 against shear failure? So here we have no information on the level of water table, so we just assume that the water table is at a great depth, that is D is far greater than B, which means that no effect on our general shear failure formula. So this is a rectangular footing where B is not equal to L, and our QU is given by 1.3 CNC plus BF NQ plus 0. So this is not 1.3. So 0.5 into gamma B in bracket 1 minus 0.2 B over L. Here is CNC into 1 plus 0.3 D over L. Just the same thing that I wrote initially. No, stop. Just
I stop.
Just stop, Abby.
Should I just stop it? I want you to just stop.
Average unconfined progressive strength is the parameter gotten from the test laboratory. Odometer test, brain shear strength test. And it gives an expression for our question C or CU, which is given by PU or 3. So to get the question of this question, it's going to be given by 45 divided by 2, which gives 22.5 kilonewton per meter square. So what don't we have?
Now
we have our C. We don't have our angle of internal friction. To undergo this test, the soil must be saturated from the top to the ground level. That is, the entire soil is saturated, and once a clay soil, I think the question said the subsoil is clay which has an average 1.5 compressive strength of 45 kN per meter square. Once clay is saturated, it has no angle of internal friction. That is, the clay layers, they don't come together anymore. They don't have any level of friction when they rub against each other. So angle of friction will be given by 0. So you check your table at 0. Right now.
Give me a diagram.
So when I check my table at 0 degrees, I should get my NC to be a value, NQ to be a value, and N gamma to give another value. I think
Louder.
Should be about 5.7. NQ should be 1 and N gamma should be 0 at 0 degrees. So immediately, if N gamma is 0, that is, this entire expression becomes null and void. Remember we're giving Q allowable. And Q allowable is given as QNU over F plus gamma DF. You can reduce this expression to become QNU, where we just add NQ minus 1 at the back end. So if you do NQ minus 1, when NQ is 1, this expression also becomes null and void. That is, you are left with only this first part of the question. And our final formula for net ultimate drain capacity is given by CNC into 1 plus 0.3 D over L, where D is 14, L is 21, we have our C, we have our NC. So this should be 22.5 times 5.7 in bracket 1 plus 0.
What's plus?
So the full expression is this, and after calculating, the base of QNG to be about 153.9. Again, let me just go over. I think earlier I mentioned having nothing to do with the water table, but in reality, the entire soil is saturated due to the drain test that was carried out for us to get our Q to be equal to 45 kN per meter square. So we use this to get our question, and we realize that once this soil is saturated, our phi becomes 0. There is no angle of internal friction. If angle of internal friction is 0, we have our NC, NQ, N gamma is nothing from the table. You can get the table in Aurora, in Praja, in DNS Multi, you can get it online anyway. Once N gamma is 0, the third part of the equation is void. Once NQ is 0, to calculate QNU, NQ minus 1 will also give 0. Second part of the equation is void. So we are left with CNC into 1 plus 0.3 D over L. So we get our QNU to be 153.9 kN per meter square. Moving on, we have our normal expression that says Q allowable is equal to QNU over a factor of safety, which was given the question to gamma DF. Okay, so since the soil is saturated, our gamma here will be gamma 5. We are looking for DF. We have our QNU. Q allowable was given the question as 140. We have our factor of safety as 3. So let's make our DF equal to formula. We will have something like Q allowable minus QNU over factor of safety. Just bring it up. Again, it's very important to draw this diagram when you are solving this question, especially for exam value. Subjective.
But
In case where your exam is not objective.
what are you insinuating, sir? What are you trying to say?
This was made in the year 2021.
Yeah, this was made
Oh!
when COVID struck.
The year of the virus.
Can't relate.
So Q allowable was 140, our QMU is 153.9. Our factor of safety should be given as 3. English and calculator should get 140 minus 153.9 divided by about 88.7, which is our gamma prime here. So to get here, should equals to 88.7 divided by gamma prime, which is 88.7. Remember, gamma prime is gamma saturated minus gamma water. You have to assume that the gamma given was saturated, and the unit rate of water is constant at 9.81. So when you do this, you should get
Your voice, please. Can increase it, please.
get the depth of about 9.65 meters.
Voice.
So I think this is the end of the question. And when you have to get the depth.
Gracias.
Hi guys, so I'm fixing a question 2017 question 1C. Question is on the question is on what's the question? Brain capacity and brain capacity. So this is our question and this is the diagram. So in this question here, according to the square footing, according to this diagram, footing is subjected to an eccentric load. Basically an eccentric load is basically when the footing is not loaded at the center. As you can see this diagram, this is 3 by 3, it is a square. Are you with me? And this thing is not loaded at the center. See this EX I have here, it means it's loaded somewhere far from the center. Now it could be far from the center on the x-axis and it could be far from the center on the y-axis. Basically is what I mean. This is a square here. We have something like this is the coordinate. It could be loaded here, like the case I have here, it is loaded here. Now it could be loaded here, it's also eccentric. It could also be loaded here. It could be loaded here, 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 here. Basically when it's not loaded at the center, it's eccentric. So since I have that, we cannot continue and say it's loaded at 0.3 meter in the x direction only. That's what I have here, 0.3 meter. So determine the gross allowable load and the footing that the footing can carry using Mayer formula. So as you guys can see this whole diagram is also at the back. We'll be making reference to it little by little. So Mayer formula is also in the PQ, but for people's sake, I'll write down Mayer's formula. Mayer's formula is QU because this is FNQ SQ DQ plus I'll continue here, which is 0.5 gamma B L gamma and D gamma S gamma. So now this is your unit weight. Unit weight is given in the diagram. Then df is the depth. As you can see in the diagram, df is 1.4. That's the depth of the foundation. NQ, you can get NQ out. SQ, shape factor. DQ, depth factor. All these things will be solved out as we go on. Now, so let me write out my givens. My first given, I have this is saturated is 1950 milligram per liter. I have my unit weight, which I mentioned here, 17 milliliters per gram. C equals 0 and this equals 40 degrees.
Oh, that's why there's no CNC in this one.
Yeah, that's why there's no CNC in the beginning. Please, so guys, take notes. In the beginning, we used to have CNC there, a whole bunch of discontention. But I don't have that here because my question is.
And the difference between Tezagi and Mayoff is the addition of.
The addition of all these. Yeah,
Well,
this is
this
basically
one,
this one and this one. That's the difference between them. Mayoff actually considers shape factor, the shape of.
Is there a table for SQ and TK from the other?
Their formulas,
So
okay.
because we came to this world to coordinate here.
To continue now. Alright, so I will speak directly into getting NQ and N gamma, which is this and this. Now, as David has said in the previous videos, if you have gamma, you can look at the tables to get NQ and N gamma. And from the tables, NQ equals 64.20 and N gamma equals 109.41. So with that sorted, I have this. For this question, I have this. I have my bread and I have this. So what's left for me is my SQTP, D gamma, S gamma. So roll with me, guys, as we get our solutions. Now, I'm going to have to explain a quick, I have to make a quick analogy. Now, okay, so guys, I want to explain something very, very important here. Now, this is what I call effective breadth and effective length. Now, imagine I have a particular. This book is representing my rectangle as it is, and I have load somewhere around here, and this is like the center here. We're going to start here. Now it means this load, the load acting here will press more on this side, more than this side. Like this place will feel the effect of the load more than this side. Meaning I'll be having B prime. That's what's actually causing the L prime and B prime I'm going to show you guys now. Now, due to the fact that my load is on this side, this part of my foundation will feel more of the load, more effect, more pressure, because it is not in the center, because on this side. So meaning I'll be having basically some inactiveness, and you can put it as that, on this side, and more of this side will feel pressure. Do you get? And this place is my B prime. How do I get my B prime? My B prime is basically B, which is total breadth, minus 2 times of my eccentricity. Eccentricity here is 0.3. So my B prime is basically the breadth, which is 3, minus 2E is 0.3. So I'm having
2.4.
I should have here 2.4. Do you guys understand? So let's say, for instance, let's just run this quickly. If my eccentricity were to be here, like the load was actually acting here and the eccentricity is here, it means I will have a particular L prime due to this, and this place, some parts here will be ineffective, and I'll be having L equals
L prime
equals L minus 2E, and I'll be having
3Y.
2Y, sorry, yes, only Y out is Y. Yeah. So it's just that, and I will need that to continue my working. So this is this. So from here I can continue. Yep, I can fill up this formula real quick. And yes, continue. So I told you I want to get SQ. Please put that in mind. I want to SQ, DQ. I want to get S gamma and D gamma. So my SQ formula. So there are actually some arrays of formulas I want you guys to code, not because of only this example, but because of other things, because of exam. Yes. So I have SC. Remember in the beginning. Basically, all this S and whatever is shape factor. Let me see. Shape factor. So, now it was due to the fact that shape factor, guys, shape factor is SC,
Q,
SQ, and S gamma. So SC is 1 plus B over this formula is important, guys. It's important to get into these things. And SQ is 1 plus B over L multiplied by tan phi. And S gamma is 1 minus 0.4. So these are the formulas for shape factors. The shape factor formulas for your question part, for your Q part, and for your gamma part. So also depth factor. Way of those trying to give different formulas for different situations. Now, depth factor. Now, you know what we call DF, which is depth of the foundation. Now, Mayoff gave, if you have your depth factor divided by your breadth to be less than 1, you have different depth factor for
that's a shallow foundation.
Yeah, for a shallow foundation, basically. And if your depth factor all over B is to be greater than 1, you have also other depth factor for you. So when it is less than 1, your DC equals 1 plus 0.4 Z over B. Your DQ equals, this is quite long, 1, let me write it. DQ equals 1 plus 2 tan phi into bracket 1 minus S phi square, this is all square, and multiplied by Z over B. Then this equals 1. So this is this for this, guys. Please, I need to follow up on you. I just need to feel like go up, so I don't want to feel the So next thing, so for when D is greater than 1, when D is greater than 1, I have my DC equals 1 plus 0.4 tan this part, this all over Z over. Please, I'm very sorry. Z, I'm writing to the same thing as DF. Please don't get it mixed up. Don't start thinking where Z is. Z is the same thing as DF. So Z over B. That's for that. My DQ formula, please, I'll leave here because my DQ is quite long. So I'll leave it and come up here. DQ is 1 plus 2 tan phi into 1 minus, alright, sine phi all square. Tan so yeah, that's that about that. I think this is also one for that case. So I also have inclination factor.
Oh, so the difference is just that you have arctan for the Z over B,
yes,
when it's greater than 1.
Yeah, just for logic. Yeah, when it's greater than 1, you have arctan.
Z over B. So D gamma does not have Z over B. There's no name.
Yeah. Yeah, and this one here, you also have arctan here on this side too. Then you have one more factor here considered. One more factor that may have considered is the inclination factor. Say your footing is inclined at some point. So you have to put inclination factor. Inclination factor is I. So yeah, if you have now, just when you have I and DC, DC and you can have IC. But in this case, IC equals IQ. Equals 1 minus this all over 90 is all square. And you also have I number equals 1 minus
So we're supposed to learn all these things.
Yep. And this is equals to
Wow.
inclination of load to the vertical. It's the inclination of load to the vertical. You can just write all this down, Sha. So yes, these are the formulas you need to write down. So back to solving, back to being normal. Yes, so the formulas I've given you guys. SQ equals 1 plus B prime over L tan 5. So if this is this, I gave you that B prime equals 2.4 from our the other time. So I'll be having 1 plus 2.4 all over 3 tan 5. 5 was given to us. 5 was given to us with 40. So to solve this out, we have 1.67. That's S2. Next thing to solve is S gamma. S gamma is 1 minus 0.4 B prime all over L. Solving this, I have 1 minus 0.4 into what's B prime? B prime is
2.4 or divided by 2. So the L is not L prime.
Yes, L is not L prime. I explained L is not L prime because I'm not having my load being eccentric on my y-axis.
Okay.
Exactly. I drew a very small diagram, and if it was acting, I'll be having some shifts.
So if it's acting in the middle point,
if it's acting in the middle part, everything will be good. L and B. Everything will be okay.
is it possible to have L prime and B prime?
It's possible to have L prime and B prime. I explained that also. If you have a situation where you don't have the load on any of the axes, basically you have a load here. So meaning the load is acting there, having more force on this side. That means from there to there, I'll be having L prime, and from here to somewhere around here, I'll be having L prime.
Okay.
So it's not going to be balanced for this because the load is like pushing. Now I have this book, and load is pushing to only this side. That's what's matter. Imagine. So on to the next one. I have oh my god. Is on to the next one? Wow. Yeah. So getting something for my DQ and my D prime. DQ and my D prime. Apparently, when I check the conditions for when you do Z over B, I told you have a condition. You have to do Z over B. So basically when you do this, that's Z over B prime in our case. 1.4 divided by 2.4. You have 2.5 over B, 1.4 divided by 2.4. You have 0.58, and that's basically less than 1. So you have to use the condition where for depth factor, your DQ, you have to use the formula where the condition says Z over B prime or Z over B is less than 1. So that takes me to using the other formula I did, 1 plus 2 times 5 into 1 minus 5 all square Z over B. So putting everything where everything is needed, I have 1 plus 2 times 40 into 1 minus 40 all square all over 1.4 all over 2.4. Everything being equal, Akanmu's calculation being correct, I should have this.
Really, please, I will make mistake.
So guys, if you recollect, I have all the parameters I need to solve my QU formula. All I just have to do is put everything into Q directly. So yes, I also have to do this. This video too is no play chill. I'm not reading it. Just play it. Please. So QU equals. So you have the QU formula from the beginning. All I just have to do is put everything into it.
Just one question.
Just one question, bro.
And it's sweet.
It's not sweet. It's not sweet. Okay, I think I should write key formula. Key formula I'm having is into the F N Q S T D Q plus 0.5
into gamma B and gamma gamma.
Actually, it's because I want to get my what's it called?
Gamma saturated.
Gamma saturated. I usually have to get gamma saturated. So I have a density. This density when the sun is saturated. So I'm just trying to convert this to gamma saturated this part. So just the way you have kilogram here, I'm trying to convert my kilogram to weight, and that was multiplied by gravity, which is 9.8 divided by 1,000.
To get in kilonewton.
So when you punch this, you have 19.1 kilonewton. So I have my gamma saturated. It's flowing. So if this be this, I can now come back into there and say my gamma prime is gamma saturated minus gamma water, which is 19.1 minus 9.8 multiplied by the place that has that issue 0.9. So if I solve that out actually, if I solve that out, I should be having, I want to do that separately, guys. I have 8.5 in this space, and I have 19.9. I have 8.9. I think it's
3 dates. Okay.
I have 16 kaku balls kaku. So now from here I can now put this back into this place. Mind you, I've multiplied my DF with it already. So basically this whole thing is what I have.
Oh.
Is what I have here. I've solved this one out. So I'm just putting this back here and go with the rest of the formula.
Alright,
So my
boss.
Q is 16.888 multiplied by, I got my NQ from the beginning to be 64.2 multiplied by SQ to be 1.67 multiplied by DQ to be 1.125, then plus flying over to the next line. I have 0.5 multiplied by my gamma. Now I explained to you that this part gives every other thing beneath the foundation. So the gamma I'll be having here will be moist because that place is like saturated, and the sand I have here, I'm looking for the weight of sand. So the weight of sand here will be gamma saturated. That's gamma saturated minus gamma of water to get the weight there. That will be 19.1 minus 9.8. Then my breath, which is my B prime, is 2.4. My NQ,
N gamma.
huh?
N gamma.
N gamma. Oh, sorry, N gamma. See why you should have wonderful feeling. People that will be watching this video 10 years after have wonderful feeling. Have friends like Victor Ibe. Have friends like Victor Ibe. 0.6 years. So at the end of all these nonsense and jargons,
The answer of Q.
yeah, my QU will be equal to 3061.8.
Is it factor of 6 we are looking for here?
What?
What are we looking for?
We're looking for drain capacity.
Okay, no factor of 6.
We are still proceeding, we are still moving to because what we're actually trying to look for here is the load.
allowable load.
I'm trying to get the load.
The allowable load.
Yeah, the allowable
Making was factor of 6.
The regular factor.
So we now use the normal formula.
Exactly.
Okay.
So we get QNU next.
Yep, you get me next.
Then you could have found QNU first, but use this method, no problem.
As you can see, guys, people that are in this room are actually on fire. I'm just following the script. I'm just following the script. I'm using, just so you know, I'm using Akanmu script. So, God help my soul. So, Q allowable, this is the formula. Q allowable equals to Q NU all over F plus F. Now, I have QNU. Please, guys, go with me. QNU. QNU is after by this QNU equals QNU minus gamma. So I can put this into this formula and say Q allowable is equal QNU gamma all over gamma.
You got your gamma DF as 16.888 before.
Oh, I think that's not helpful. So my Q or you know Q which is 3061.8 minus 16.888 all over. My factor of 60 was given in my question to be 4. Please check the question. It was 16.888. Punching this, I should have 778.12. So if this is my Q allowable, so this is, as you can see, plurality packet square, and I'm trying to get your plurality. So it means that Q allowable equals Q multiplied by Q.
Huh? So the other way.
So Q divided by Q. As I said, one way to say. So if I cross multiply, Q equals to Q multiplied by Q allowable. What is my area? My area is 2.4 multiplied by 3.
So A is it L prime B prime or B prime L?
Oh, yes, that's very, very important. And A is equal to B prime, which is a B effective, multiplied by L.
Okay.
Then Q equals, this was what it is. Yeah. 5, 6, 0, 2, 4. Now, for more writing,
Shall they tell them say I no get fine handwriting?
I know I got to tell them, but look my final writing to get 5 points. Let me see.
What is 5 points?
6-4. Yeah, Akanmu is correct. So
CGPA
CGPA doesn't
doesn't matter in
matter in level. And I wanted to dance at the end of the video.
So how you doing?
I'm done. Thank you for
Thank you
very much.
subscribing.